Hello my dear children, welcome to maths class. Today we are going to do the last problem in the second exercise of this chapter, that is page number 109, question number 5. That is the fifth question. A triangle is to be drawn with one side 8 centimeter. Okay, this one is a triangle with one side 8 centimeter and angle on it and an angle on it. Okay, that is angle on one side is equal to 40 degree. Then what should be the minimum length of the side opposite to this angle? Okay, what should be the length of the side opposite to this 40 degree angle? Okay, this is our question. Minimum length is always the perpendicular distance. Okay, minimum length is always the perpendicular distance. So, the perpendicular distance means, see, this is the perpendicular distance. This is the minimum length of the side opposite to this 40 degree angle. Okay, so how do we find this angle? How do we find this side or the perpendicular distance? Yes, we know that. Here if we consider this right triangle, we have this angle is equal to 90, this one is equal to 40. Okay, and we have this side 8 centimeter is actually the hypotenuse. Okay, hypotenuse. So for this triangle 8 centimeter is the hypotenuse, and if we compare to this angle 40 degree, the side is opposite is this side, right? Then the ratio between opposite side and hypotenuse is the sine ratio. So using the sine value, we can find out the perpendicular distance. Okay, what is sine 40? Yes, sine 40 is equal to, if we name this triangle as ABCD, okay, the ABCD, then sine 40 is equal to, yes, opposite side by hypotenuse. This is the hypotenuse and this is the opposite side of 40 degree. Okay, so we have AC divided by 8 centimeter, or we need the perpendicular distance because that is the shortest length between two sides. Okay, so AC is equal to sine 40 into 8 centimeter. Okay, sine 40 into 8 centimeter, and the value of sine 40 is 0.6428. Okay, so 0.6428 into 8, that is equal to 5.1424. Okay, and if we take the value corrected to two decimal places, we can take this length as 5.14 centimeter. So that is the minimum length of the side opposite to this angle. Okay, minimum length is always the perpendicular distance. Keep in mind, minimum length opposite to an angle is the perpendicular distance. Okay, so the perpendicular distance is equal to 5.14 centimeter. Okay, so that is the end of the second exercise. Now we are coming to the next topic, that is triangle and circle. Our next topic is triangle and circle. See, here you can see the central angle of this chord. BC is a chord of the circle. This BC is a chord of the circle. If we have the central angle of this chord, can we find out the length of this side? Okay, that is, using the central angle, can we find the length of the side or length of the chord of a circle? Can we find out the length of a chord of a circle? Let us check. See, here we have AB and AC, right? AB and AC. What is AB and AC here? Yes, AB and AC are two radii of the circle, right? AB and AC are two radii of the circle. That means they are equal. Radius are always equal. So we have AB is equal to AC. So if we consider the triangle ABC, it is an isosceles triangle. Okay. So we have an isosceles triangle ABC here with AB and AC are equal. Then we know that their base angles are also equal, or the angle opposite to equal sides are also equal. Then what will be these two lengths? We know that the sum of angles of any triangle is 180. Okay, and out of which one angle is equal to 60. Okay, then the sum of the other two angles is equal to 180 minus 60, that is equal to 120. Okay, and each angle, both angles are equal and their sum is equal to 120. Then each angle is equal to 120 divided by 2, that is equal to 60 degree. So we have this equal to 60 and this one is equal to 60. So what do you mean by this? Yes, this one is an equilateral triangle. Okay, this triangle ABC is an equilateral triangle. So in an equilateral triangle we know that all sides are equal and all angles are 60 degree. So what can be understood from this? Yes, if the central angle of a chord, if the central angle of this is BC is a chord and the central angle of the chord is 60 degree. Central angle of the chord is 60 degree. Then the length of the chord is equal to the radius of the circle, right? All the sides are equal. We know that these two are the radius of the circle. Then the third side is also equal to, or the length of the chord is also equal to the radius of the circle. Okay, so if the central angle of a chord is 60 degree, then length of that chord is equal to the radius of the circle. That means if we have the central angle, we can find out the length of the chord. Okay, and if another angle is the other than the 60 degree, what happen? Let us check. What if the central angle is 120 degree? First I am going to name this triangle as ABC. Then if the central angle is 120 degree, then what will be the length of this chord BC? That is our question. Okay, how do we find the length of the chord BC if its central angle is 120? So here the central angle of the chord BC is 120 degree. Now I am going to find out the length of the chord BC. Okay, using our sine ratio. Okay, for that I am here going to draw a perpendicular from the third vertex to the base. And this triangle ABC is what type of a triangle it is? Yes, since AB and AC are equal, we can say this triangle is an isosceles triangle. Okay, triangle ABC is an isosceles triangle since AB and AC are the radii of the circle. Okay, so these two are the radii of the circle. And if we have the central angle is equal to 120 degree, what about these two angles? Yes, that two angles are equal to 180 minus 120 divided by 2, right? One angle is equal to 120, then the sum of other two angles is equal to 180 minus 120, that is equal to 60, by 2 is equal to 30 degree each. So these two angles are 30. Okay, so if we consider this triangle, if I name this point as D, we have two triangles. One is triangle ABD and other is triangle ADC. Okay, and for this triangle, if we consider the triangle ADB, we have this angle is equal to 30, this one is equal to 90 because this is perpendicular to the base. Okay, in an isosceles triangle, the perpendicular drawn from the third vertex to the base bisects the base, keep in mind. Okay, that is bisects the base. And see, what about this angle? This is 90 degree, this one is 30, then the third angle is equal to, yes, 60 degree. This is also equal to 60 degree. Okay, so we have a 30, 60, 90 triangle here. Okay, 30, 60, 90 triangle here. Then here we have, yes, the angle opposite to the side opposite to this 90 degree, the side opposite to 90 degree is the radius of the circle, right? 90 degree, opposite to 90 degree, we have the radius of the circle. Then what is the side opposite to 30 degree? We know that in a 30, 60, 90 triangle, the side opposite to 2, okay, side opposite to 1. Then if side opposite to 90 is R, then what will the side opposite to 30? Yes, half of this R, right? That is equal to R by 2. So we have the side opposite to 30, that is this perpendicular distance is equal to R by 2. And what about the side opposite to this side, that is this angle 60 degree? Yes, the side opposite to 60 degree is root 3 times the side opposite to 30 degree. Okay, root 3 times the side opposite to 30 degree. So root 3 into the side opposite to 30 degree is R by 2. So we have root 3 R by 2. That is, this length is equal to root 3 by 2 R. Okay, this length is equal to root 3 by 2 R. Then what about this side? That is also equal to root 3 by 2 R. Okay, then what will be the total length of this chord or the side of the triangle? Yes, this part is equal to root 3 by 2 R and this part is equal to root 3 by 2 R. So the total length is equal to, yes, total length is equal to root 3 by 2, root 3 by 2 R plus root 3 by 2 R. Okay, so that is equal to, yes, 2 root 3 R by 2. Okay, 2 root 3 plus root 3, 2 root 3. Here the denominators are same, so put the same denominator here. Then see, here we have 2 and 2 common. So let us cancel that. Then we have the side is equal to root 3 R or R root 3. So what is this root 3 R? Yes, this total length is equal to R root 3 or root 3 R. That length is actually the root 3 times of the radius of the circle. Okay, root 3 times of the radius of the circle is the length of the chord. When the side, the angle, the central angle of the chord BC is 120 degree, then the length of the chord is root 3 times of the radius. Okay, root 3 times of the radius. So if the central angle is 60 degree, if central angle is 60 degree, length of the chord is R. And if the central angle is 120 degree, the length of the chord is equal to root 3 times of R. Then if another angle is there in the center, what happened? Let us find out. See, here we have a triangle ABC and I am going to take the central angle of the chord BC as, yes, here the central angle of the chord B as 2x. For convenience, I am going to take the central angle of this chord B 2x. Okay, 2x. Then what will be the length of the chord? That is our question. What will be the length of the chord BC? How do we find this? Okay, so we know that this ABC is an isosceles triangle. This ABC is an isosceles triangle. Then if we draw the perpendicular from the third vertex to the base, yes, we get a right triangle. Two right triangles here. One is triangle ADB and other is triangle ADC. And what about this angle? This angle is equal to x degree and this angle is equal to 90 degree. And what about the third angle? Yes, that third angle is equal to, yes, 90 minus x, right? One angle is equal to 90 degree and second angle is equal to x degree. We know that sum of these two angles also equal to 90, right? One angle on itself is 90 degree, then the sum of other two angles also equal to 90 degree because the sum of angles of any triangle is 180 degree. So if this angle is equal to 90 degree, the sum of other two angles also equal to 90 degree. So if one angle is equal to x, then the other angle is equal to 90 minus x. Okay, similarly we have this angle is equal to x, this one is 90 and this angle is equal to 90 minus x. Okay, now I am going to find out length of this chord. Okay, length of this chord or this portion. Then how do we find this? If we consider this angle x, okay, if we consider this angle x, what is sine x? What is sine x? Let us see. See, this is the radius of the circle, or that is the hypotenuse of the triangle. That is the hypotenuse of the triangle, and also it is the radius of the circle. Okay, this is the hypotenuse of this right triangle ADB, and also it is the radius of the circle. Okay, so here we have this is equal to x degree. Then with respect to this angle x, how do we find this length BD? Yes, that length BD can be determined using the sine ratio, right? What is sine x? Yes, sine x is equal to, yes, what is sine x? This BD, opposite side by hypotenuse, okay, opposite side by radius of the circle. Okay, opposite side by radius of the circle. From this, what is BD? Yes, BD is equal to, R into sine x. Okay, R into sine x. Then similarly we can find out this DC is also equal to, yes, this DC is also equal to R into sine x. Okay, R into sine x. Then what will be the total length of this BC? Yes, this total length BC is equal to R sin x plus R sin x. Okay, so that is equal to R, 2 R's are here. So R sin x plus 2 times of a thing means that is 2R sin x. Okay, same things repeated 2 times. So that is equal to 2R sin x. Okay. So we have length of this chord is equal to 2R sin x. What is R? R is the radius of the circle. Okay, R is the radius of the circle. And what is x? X is half of the central angle. Right? Half of the central angle. This x is half of the central angle. We take the central angle of this chord as 2x in the beginning. Right, and if we draw the perpendicular, we get this two angles are x each, right? So this x is actually half of the central angle. From this we can understood one relation. What is the relation? If we have the central angle of a chord, we can find out the length of that chord using this formula. Okay, if we have the central angle of a chord, we can find out the length of the chord using this formula 2R sin x, where R is the radius of the circle and x is the central angle of the chord. Okay. Using this formula, can we find out length of this chord BC? How do we find length of this chord BC? Yes. Using the formula, we have 2R sin x is length of the chord BC. What is R here? R is the radius, that is given as R itself, right? And how do we find this BC? Yes, BC is equal to 2R sin x. Okay, 2R sin x, where x is half of the central angle. Keep in mind, half of the central angle. Okay, so this equal to 2R into sine. What is here? The central angle is 100. What is its half? Yes, so that is equal to 2R sine 50. Okay, so if we have the length of the radius, we can find out the length of the chord using this formula. So if we have the radius of a circle and central angle of a chord, we can find out the length of any chord of a circle. Okay children, so this is the result 2R sin x, or we can write this x as c by 2, that is easy. Okay, that is 2r sine c by 2, where the c is the central angle of the circle. C is the central angle of the circle. So for any chord we have the central angle, we can find out its length by using the formula 2r sine c by 2, where c is the central angle of the chord. Okay, now we have some problems based on this idea. We will do the problems in the coming classes. Okay, so today we are going to wind up this. Thank you children. Thank you.